Okay, so today we will get started with past papers using what we have already learned. So this is a question from May-June 2019. Let's try that. So the question has given us a cubic equation x cubed plus bx squared plus cx plus d equals to 0, which has real roots alpha, beta, and gamma. Okay, so the question has given us two key informations, which is that sum of inverse of root is equals to minus 5 over 12, and product of roots alpha, beta, gamma is equals to minus 12. Now the question wants us to find the values of C and D, which we can do pretty easily. So let's first revise what we have already learned. So this is Vieta's formula for cubic equations. Uh, Sum of roots is equals to minus b over a. Sum of pairwise roots is equals to c over a, right? And product of roots is equals to minus d over a. So let's get back to this. So as you know, the product of roots is equals to minus d over a. So product of roots, this is equals to minus d over a, right? And the value of a is actually given. Since there is like no coefficient next to x cube, so the coefficient with x cube is basically 1. So the value of a is basically 1. So we can write this as minus d. Okay, so what is product of roots alpha, beta, gamma is equals to? It is actually given in the question, which is equals to minus 12. So minus d is equals to minus 12. Let's make d the subject, and yeah, the value for d is 12. So now let's try finding the value of c. So summation of inverse, sum of inverse of roots, this is basically 1 over alpha plus 1 over beta plus 1 over gamma. And this is equals to minus 5 over 12, which is given in the question. Minus 5 over 12. So let's first take LCM for these. This get multiplied here and this get multiplied here. So let's do that. Alpha plus beta plus alpha beta plus 1 over gamma, which is equals to minus 5 over 12. Okay, now let's take LCM for this. So alpha gamma plus beta gamma plus alpha beta over alpha beta gamma. Now, if you guys see this carefully, this is basically sum of pairwise roots. And this is product of roots, right? And as we know that the sum of pairwise roots is actually given by C over A, right? Sum of pairwise roots is equals to C over A. So since we know the value of A already, which is 1, so we can just write C here, right? C over, and the question has already given us the value for alpha, beta, gamma, which is minus 12, right? So let's input that, minus 12. Okay, and this is equals to minus 5 over 12, which is also given by the question, minus 5 over 12. So 12 goes to the other side. Here it is being divided, so it will be multiplied in the other side. So C is equals to minus 5 multiplied by minus 12 divided by 12. Okay, so 12 and 12 gets cancelled, and minus 5, we will end up with minus 5 multiplied by minus 1. So value for C is 5 because minus and minus get cancelled. So this is basically free 3 marks. This is a really easy type of question. So now let's try something more difficult. Okay, so question number 4 from May June 2018 paper. This is slightly trickier question but also easy. This is of 6 marks, so let's read the question. It is given that the equation, which is a cubic equation, x cube minus 21 x square plus k x minus 216 is equals to 0. Let's rewrite the equation. X cube minus 21 x square plus kx minus 216, which is equals to 0. Okay, now k is a constant and this equation has roots. This is important. This equation has roots. What are the roots for this equation? A multiplied by r, and a over r, which is basically equals to a r minus 1. Since r goes up, it becomes r raised to the power minus 1. So let's write it as a over r, so things stay pretty simple for us. So yeah, the question is asking us to find the numerical values of the roots. So yeah, we have to find the value of a over r, and a over r, and a multiplied by r. Okay, so how can we do that? We can relate this equation with our Vieta's formula. So let's do that. So sum of roots, sum of these should be equal to minus 21, right? We have learned that the sum of roots a plus ar plus a over r is equals to minus b over a, right? Sum of roots is equals to minus b over a, right? So the value of a here is 1 because there's no coefficient of with x cube, so it's basically 1 here. So the coefficient of x square, which is b, so b is minus 21, c is k, and d is minus 216, right? So yeah, let's input these values here. So sum of roots a plus a r plus a over r is equals to 21. Minus minus gets cancelled out, and we will be left with positive 21. And since there's like value of a is 1, so we write nothing below 21. So this is our first equation. So let's just leave it like this for now. Okay, so now let's try product of roots. So what is product of roots is equals to a multiplied by a r multiplied by a over r. Okay, so r and r gets cancelled, so a cube. So what is this equals to? What is product of roots is equals to? Let's revise from our Vieta's formula. Product of roots is equals to minus d over a. Okay, so this is equals to minus d over a. We know that the value of a is 1 and minus of d is 216. So minus 216. So minus 216 divided by 1. So we are left with 216, which is equals to a cube, right? So yeah, let's take cube root both sides. This gets cancelled, and yeah, so a is equals to cube root of 216, which is equals to 6. Okay, now since we have found the value of a, we can easily input it here and make and solve for r. Okay, so let's try that. So 6, let me change the color. 6 plus 6r plus 6 divided by r is equals to 21. Okay, so now let's solve for r. How can we do that? By multiplying whole equation by r, because we don't need r as a fraction anymore. So let's try that. So 6 multiplied by r, 6r, 6 multiplied by 6r multiplied by r, 6r square, and r multiplied by 6 over r and r gets cancelled, so we are left with 6, and 21 multiplied by r is 21r. Okay, so let's take 21r over to the other side. This will be 6r square minus 15r. 6r minus 21r is equals to 15r minus 15r. So minus 15r plus 6 is equals to 0. This is our quadratic equation. We can either use quadratic formula in our calculators or use middle term breaking here. So in the end, we will get the value of r as 0.5 or 1 upon 2, and other value of r would be 2. So now let's try inputting these values of r in this equation and see if these both satisfy, just to make sure that things are correct. So let's try that. 6 plus 6r. Let's first try r as 2. So 6r, 6 multiplied by 2, 6 divided by 2 should be equals to 21. Let's see if this side is equals to 21. 6 plus 12 plus 3 equals to 21. 21 equals to 21. So now let's check with 0.5 or 1 over 2, whatever you want to call it. So r is equals to 1 over 2. So it would be 6 plus 3 plus 12 equals to 21. Again, this satisfies our equation. Let's now find the numerical values of the roots. So a is equals to 6, right? This is our first answer. And ar is equals to, the value of a is 6 and r is 2. So value of ar is 12, right? So this is our second answer. Let me just make a square with red. Okay, now a over r, the value of a is 6, r is 2. We can also input 0.5. We will still get the same answer, 1 and 3. So a over r, or a r to the power minus 1 is equals to 3. This is our third answer, and we have solved this equation. This is literally free 6 marks. It just requires you to manipulate the roots using Vieta's formula. Okay, so this is a question from 2017, May, June. This is of 8 marks. This is literally not even hard. This is easiest we have done so far. So let's try that. So you guys can see that this is like the easiest question. So yeah, by finding a cubic equation. So our objective is to find a cubic equation. How does a cubic equation looks like? It looks like ax cubed, oh my gosh, ax cubed plus bx squared plus cx plus d. This is how our general cubic equation looks like. But most of the time there's like no coefficient with x cubed, right? So let's divide whole thing by 1 over a. So we are left with no equation with x cubed. So x cubed plus b over a x squared plus c over a x plus d over a, which is equals to 0, right? So this is what we will use to solve this question. Okay, so this equation has roots alpha, beta, and gamma. So we have to solve the set of simultaneous equations to find the cubic equation. Okay, so we are given that alpha, beta, the sum of roots alpha plus beta plus gamma, sum of roots, which is equals to alpha plus beta plus gamma, which is equal to which is equals to -1, right? And we know that this also equals to minus b over a. This is the Vieta's formula for sum of roots, minus b over a. Yeah, here. So sum of roots minus b over a, sum of pairwise roots c over a, and sum of roots minus d over a. So let's implement that here. So now we know that -1 is equals to minus b over a because we used Vieta's relations. So let's make b over a the subject, which is our coefficient of x square. So b over a is equals to 1. So our cube equation looks like this so far: x cube plus 1x square plus c over a plus d over a equals to 0. Now we have to find the value for c over a. So let's do that. So yeah, in the last class we learned how to deal with sum of square of roots. So it follows a pattern which is very thick. So a square plus b square plus gamma square. Whenever we have an equation like this, it will always follow this pattern. Okay, so let's try that. This will be equals to minus b over a square minus 2c over a. We learned how this works in the last class, so make sure to watch that. Yeah, so minus b over a, we are given the value for that already, which is 1 minus 1 minus b over a is equals to -1, right? So let's input that here: -1 square, and we are given in the question the value for sum of square of roots, which is 29. So this is equals to 29, this part. So let's solve for c over a. Let's make this the subject. So this becomes 1 and then goes towards the other side, so it will become 28, which is equals to -2c over a. Let's take this to other side. Here it is being multiplied, so on the other side it will be divided. So 28 divided by -2, so 114. So we are left with -14, which is equals to c over a. Now let's rewrite our quadratic equation. X cube plus x square with coefficient of 1. I'm just not writing it here because it's 1. And c over a, coefficient of x. I forgot to write x here, which is -14, -14, -14x plus d over a. Okay, so now let's find d over a, value for d over a. So we are given that the sum of inverse of roots is equals to -1. So sum of inverse of roots, let's solve this here. Sum of inverse of roots is equals to -1. So sum of inverse of roots is basically 1 over alpha plus 1 over beta plus 1 over gamma, which is equals to -1. Let's take LCM for these. Alpha plus beta over alpha beta plus 1 over gamma. Now let's take LCM for these. So alpha gamma plus beta gamma plus alpha beta over alpha beta gamma, which is equals to -1. Okay, now as we have already found the values for so in a cubic equation, sum of pairwise roots, let me copy and paste that here. So yeah, here, here. So sum of pairwise roots, this is the sum of pairwise roots, which is equals to c over a, and we have already found the value of c over a, which is minus 14. So let's input that. We have to find the value for minus d over a, which is sum of roots. So sum of pairwise roots is being divided by product of roots. Product of roots is equals to minus d over a, and all of this is equals to minus 1, right? So minus 14 equals to minus 1 multiplied by minus d over a. So this becomes minus 14 equals to d over a. Now we have found all the values, and let's now rewrite our equation. So x cubed plus x squared minus 14x minus 14 equals to 0. This is our cubic equation. This is literally freest 8 marks. We just have to use Vieta's relation as we have been using in the past question. So this is it for today's lecture. Have a nice day.